Hello everyone. So in this video I am going to discuss about some case studies in the rapid prototyping method. The case study number 1 is the design and prototyping of Spur gear. So this is the case study on prototyping process of Spur gear using the FDM, that is fused deposition modeling method. It is a one type of rapid prototyping method. It also describes the step-by-step procedure for making the Spur gear prototype. The spur gear has teeth parallel to axis of rotation and it's used to translate the motion from one shaft to the another shaft. This is the purpose of the spur gear. The three-dimensional CAD file was generated using the AutoCAD software. Slicing is done using the quick slice software. So FDM 1650 machine was used to fabricate this spur gear prototype. Material used is the ABS plastic filament, that is acrylonitrile butadiene styrene plastic filament. These steps are the fabrication process. It consists of 4 major steps. First one is the design process, another one is the .stl file conversion, and another is the slicing. After that, it's built into the final product. The step 1, it is the CAD process. In the CAD process, a detailed CAD drawing of the part was created by using the AutoCAD software. If there is more than one component to the model that is to be created, the unity function must be used. The .stl file can only be created if the model is a solid object. The STL file is generated using the export commands. File is now ready to be sliced. The step 2 is the part preparations. The proper orientation of this model is the first step after opening the file. The optimum position of the gear is to lie flat on the ground. So the parts are sized in order to fill the build envelope. After the slicing, the part will show the various layers starting from the first layer in the bottom. So after slicing, the part will show the various layers starting from the first layer in the bottom because it is built by the layer by layer. So if the model it stands red in, it means the model needs the support structure. The software will analyze where the support is needed. Once the support is created, add a base to the part. The third step is the setup and build. The FDM machine was operating at an overall temperature of 68 degrees Celsius. The model extrusion head was operating at 270 degrees Celsius and support material head at 265 degrees. We already discussed in the theory sections for the PLA, PLA plus and APS, the melting temperatures around 270-275 degrees Celsius. In the fused deposition modeling machine, it navigates to the folder containing the model and choose the .sml file. The machine will read the information and the pause button will be flashing at this point. So a 10x10 substrate was placed into the building chamber. Set the origin of the print head and click the start printing now button. Then final step is the post processing step. In the post processing step, the support removal was accomplished with the use of simple hand tools. The sandpaper was also used to completely remove the base material from the base. So the machine can produce over the 8 different parts with completely different geometry in less than 3 weeks. There are size and material limitations, but the advantages is definitely help of the final product. So let us discuss the another one case study, reverse engineering of a model without design data. So University of Magdeburg and Germany derived its name from the Otto von Guericke, that is OVG. There was a need for a number of sculptures in several sizes of awards, souvenirs and so forth. So it was determined the necessary scaled masters is to be produced using the RP, rapid prototyping. The sculpture of OVG has no design data, hence an intelligent reverse engineering approach is needed. So in the options of design data, a 3-dimensional digitizing surface reconstruction techniques are used. These are the methodology of the reverse engineer of model without design data. The general strategy used to reconstruct the sculpture of OVG, that is Otto von Guericke, using the reverse engineering. RP and investment casting is illustrated below. That means first one is the physical model culture of the OVG and conduct the digitalizing using the CMM and creation of CAD model and rapid prototyping final product and investment casting. These are the bronze sculptures, laminated object manufacturing model, final rapid prototyping, reconstructions. The original sculpture was 650 mm high and made from the brass. The size and weight exceeded the capacity of the local available optical three-dimensional scanners. Therefore, the tactile digitizing on coordinate measuring machine with a probe was performed. The data was captured in the 500 radial profiles, creating about the 8 lakh single data points. In this situation, there are two possibilities for a valid volume representation. There are some challenges in reconstructions, or the shape was too complex for surface reconstruction. This would require the high number of surface patches. Every patches has to be connected to the neck bones precisely. The number, shapes, and the connections make a surface reconstruction is impossible. The many defects inside the point cloud made the polygonization very difficult. The original count of 2,17,000 facets was too large to handle with the existing software. A stepwise reduction to 30,000 was reached. These are the challenges faced in the reverse engineering of the sculptures. So thank you for watching.